Okay, so for this example, we have T, which is temperature outside, is a function of the chirp rate R of a snowy tree cricket, and that's given in chirps per minute. So T is a function of R, and we have that formula given to us where f of R is equal to R over 4 plus 40. And in each of these examples, A, B, C, and D, we have an expression that we want to evaluate. So for part A, here to evaluate f of 32, what this means is whatever comes in the parentheses, well, that's what we plug in place of the variable, in this case R, in the formula. And so we had R over 4, I plug in 32 for R, and now I simplify this by saying 32 over 4 is 8 plus 40, so that gives us 48. And in this case, this actually has some practical meaning, and that is when the snowy tree cricket is chirping at a rate of 32 chirps per minute, the outside temperature is going to be 48 degrees Fahrenheit. Okay, so for these others, we may not have a practical interpretation, but for the mechanics of the mathematics, let's see how we can evaluate these expressions as well. So here, the same idea, if I have f of 12R, okay, what comes inside the parentheses where I'm evaluating the function each time I were to see an R in my formula, I replace it with whatever is in the parentheses. And now we can simplify this by saying, well, 12 over 4 R plus 40. 12 over 4 is 3 R plus 40. So in part B, this simplifies to 3 R plus 40. In part C, we now are going to take 12 times the expression for f of R, which is R over 4 plus 40. And so now I'm going to multiply this entire expression by 12. So this gives me 12 R over 4 plus 12 times 40. So I'm going to distribute this 12 to both of these terms. And so now simplifying this, we get 3R plus 480. Okay, and so notice that the answers in B and C are different. Okay, so it matters whether I first take R and multiply by 12, and then evaluate the function, whether I evaluate the function first and then multiply by 12, which is what C is telling me to do. Okay, lastly, in part D, we are now evaluating the function f at 8 minus x. So every time I see an R, we are going to replace it with the expression 8 minus x. And now I simplify this. And with fractions, remember, this is the same thing as saying 8 over 4 minus x over 4 plus 40. So I can split up the difference in the numerator of that fraction. This gives me 2 minus x over 4 plus 40. And so to make this simplified here, we might as well add the 40 and the 2. So evaluating f at 8 minus x gives us 42 minus x over 4. We need to pay attention to the variable that we're used. So since our variable that was going inside was x, the expression in the end has x as the variable.